Video for today is to look at the parent function for logarithms and then graph some transformations on it. So let's take a look at what we know the parent function looks like first. We know there's a vertical asymptote here, goes through that x-intercept of 1, 0, and then that slowly increasing but flattening out growth right there. That's the parent function. And we know there are a couple of key points here. Number one, we know that the x-intercept is at 1, 0. That's always going to be the case. We also know that the log base b of itself, so whenever the x value is the same as the base of the log, well, that log would be 1. The exponent that it takes to make 5 into 5 is 1. So whatever b is, let's say it's right here, this is b, and this is the point b1. And then it takes a lot longer to get up from y equals 1 to y equals 2. In fact, whatever b is, it has to be squared in order to get the y value to be up to 2. For example, log base 3 of 9 is 2. Log base 4 of 16 is 2. Whatever b squared is what it'll take to get the y value up to 2. I didn't quite draw that to scale there. And then the fourth point here that's important to include is remember when we've got the log of a fraction is a negative number. So we kind of think of those 4 points as shaping our parent function. We'll be in really good shape. So we can make the parent function for all of these logs. And just like with the exponentials, the parent function depends on what the base is. So log base 2 of x as a parent function. We're going to use the 4 x's from our parent function, from the graph up above, and put using the base of 2. So the first one, the smallest one, is 1 over our base. That's 1/2. The next one is always 1, and then whatever our base is, and then whatever our base squared is. 1/2, 1, 2, 4. If the base was 3, so for our next example, y equals log base 3 of x, it's going to fit that same pattern. 1 over whatever the base is, then 1, then the base squared. We can do the same thing when logs are fractions too. Log base 1/2 of x, 1 over whatever the base is, well, 1 over 1/2 is 2, and then 1, and then whatever the base is, and then whatever the base is squared. Notice how this time the numbers are decreasing, and that's fine. And the y values, if we take a look at the y values, they were nice and orderly, -1, 0, 1, 2. So that doesn't even matter what the base is. Our y values are always going to follow that nice orderly pattern. -1, 0, 1, 2. -1, 0, 1, 2. And so those are our parent functions. And now you'll be able to do that no matter what the base is. That being said, let's stick to the base of 2 just to make our lives easier for our graphing. So let's take a look at a parent function, and we're going to graph it. One thing that's important to note about logs, which is a little bit different from the exponentials that we just graphed, is that logs have a restricted domain. So I'm going to find that first. The idea of the domain of a log is simple. It's just that the argument has to be positive. So the domain of my log is that -x minus 3, just the argument, has to be positive. So I will solve that by adding 3 to both sides and then dividing by 1. So x has to be less than -3. That's my domain. That's not going to change my process at all, but it definitely is helpful to say that right away, so that way I have it written down and I know when I'm done that my graph has to look like that. I have to see a graph whose domain is everything less than -3. which also tells me that my vertical asymptote is going to be at -3. X equals -3. We'll get to that in a second. Okay. From then on, we're going to do the same thing we did with the exponential graphs. We're going to list the transformations and then make a parent function and do the transformations. The order that you can make the parent table function first if you want, like I put in this order here, or you can list the transformations first. To be honest, I usually like to list the transformations first. A reminder though, every time there's a b, don't forget to factor that b out. Log base 2 of -1 times x plus 3. So my transformations, there's no a. I mean, there is an a, it's 1, so I don't have to worry about that transformation. The k is 0 in the back, don't have to worry about that. So my only transformations I have to worry about are that b is equal to -1 and that h is equal to -3. So we're going to follow the same roadmaps because of b and h that we follow for every type of function all year, including the exponentials we already did today, including the radicals we did earlier in the year, including the parabolas from when we had the graphed in vertex form, always. B tells us to divide the x values by -1 and then subtract 3. Because we're dividing by a negative, our x values are going to head backwards, which is why our domain makes sense that it's everything less than -3. And then in our parent function, and I just realized I forgot something very important on the last page. I'll go back to in a second. Our parent function is log base 2 of x, and so we'll graph the 1 over b, -1, 1, 0, b, 1, b squared, 2. And then the very important thing that I forgot, and I'll have to go back and add it into all of my parent functions on the previous slide, is that there is a vertical asymptote to the parent function for logs at x equals 0. And I'm going to include that every time I make a parent function. Notice how this time I put the vertical asymptote, I put those letters here so that I could put x equals 0 in the x column. And that way I'll remember to make the changes to that x value, the vertical asymptote, the same way I make the changes to the rest of my x values. Okay, so let's do our new transformed function, which I'll call y. And we don't need to do anything to the y values because there were no transformations, so I can just copy those down. And then for the x values, I'm going to divide by -1, so flip the sign around, and then subtract 3. 1/2 becomes -1/2, and then subtract 3. 1 becomes -1, and then subtract 3. 2 becomes -2, and then subtract 3. 4 becomes -4, and then subtract 3. And the vertical asymptote, x equals 0, changing the sign doesn't do anything, but subtracting 3 certainly does. So now I will make my graph. Notice how the y values, they're never going to change all that much. For the x values, I need my space to be negative, so I'm going to put my y-axis all the way over here. I'm going to graph my vertical asymptote first at x equals -3. And then I will plot some points. -3.5, -1, -4, 0, -5, 1, -7, 2. And there you can see the steepness that slows down as x moves backwards. I missed, so I'm going to try that. The domain we already said is x is less than -3, and the range of a log is always all real numbers.